Prango, and today I'm going to be teaching you about encryption. And encryption now plays an incredibly large role since all of us has some kind of social media account, be it a Facebook, Twitter, or unlikely a MySpace. And I'm also willing to bet that you use your credit or debit cards online to buy stuff, games, Amazon stuff, whatever. It's still important. And in an increasing use of technologies, especially Internet of Things, encryption plays a really large part. And first, what is encryption? Encryption is simply the process by which you take a regular piece of information, like maybe login information, your credit card number, or anything you consider to be sensitive, and convert it to a useless, semi-useless string of information that is incomprehensible to everyone using a special password called a key, and that data can only be converted back into the plain text by using the key as I've shown here. So for both of these things, you need to use the key. And a ciphertext without the key is useless, since it is impossible to gain meaning from it. And so, like I previously said, it protects sensitive information, but that is a pretty broad thing. So I'll just give you a real-world example that happened a couple of years ago. Apple has this service, their cloud service, where you can upload things to the program and access it anywhere. That, of course, is encrypted, and it turns out their encryption, among other things, wasn't the best. And so a group of hackers hacked into it, broke the encryption, and accessed all of the data there. And it turns out that for some reason a lot of celebrities posted nudes up there, so they were exposed out in the wild, and it hurt them a lot, understandably. But that's just an example of a good reason for encryption. It's always not that cut and dry, and there's a huge debate going on with how much encryption is good. Right here is, this is called a Caesar shift. It's just, this was invented by Julius Caesar, and all it is, the key is how many times you shift each letter. So M shifts into P, and so on and so forth. This is not really secure because there are only 25 possible keys. And back then it worked because encryption was a new thing back then. But now with all of our computers, something so simple cannot be trusted. And this comes into account with the recent terrorist attacks. The terrorists used secure communications, so the police was not able to intercept it. And this reached a boiling point with the San Bernardino shooting. The shooter had an iPhone which has a password on it, and the FBI could not break the encryption on the password and could not access the data they believed would help them save lives. So they tried making Apple unlock the phone for them, but Apple refused, so then the FBI attempted suing them. The FBI's case on this is clear. They believed it would save lives, but Apple's is not so clear, because not only did the FBI want Apple to decrypt the phone, they wanted Apple to give them the utility to do it themselves, which, if that technology were released in the public, then every single iPhone would be at risk of being decrypted, and all of the sensitive information you have on your phone would be at risk. So that is just a basic rundown on what encryption is. Right now there are a lot of more complicated things like asymmetric encryption. Like this is symmetric encryption since the same key is used to encrypt and decrypt, but with asymmetric it's different keys. And the reason is some very complicated math stuff, but it somehow works. And that provides a lot of security, but that is too complicated of a stuff to go over in a 5 to 7 minute lecture, sadly. And so I just hope that all of you have a better understanding of encryption and why it plays such an important role in our lives.